Hello everyone, welcome to lectures on matrix algebra. In today's lecture, we are going to discuss about Hermitian matrix and skew Hermitian matrix. First of all, let's discuss about Hermitian matrix. A matrix A is called Hermitian matrix if it is transpose conjugate of itself. So A will be equal to A theta. The conditions for matrix to be Hermitian are: number 1, the matrix should be square matrix. Number 2, the ith element should be complex conjugate of jth element. And number 3, the diagonal elements of the matrix should be real. For example, let's A be a matrix whose elements of first row are A11 equal to 1, A12 equal to 2 plus 5i, A13 equal to 6 plus I. The elements of the second rows are A21 equal to 2 minus 5i, A22 equal to 2, A23 equal to minus I. And the elements of the third row are A31 equal to 6 minus I, A32 is I, A23 is 4. If we take the complex conjugate of these elements, then we get A11 star is equal to 1, A12 star equal to 2 minus 5i, A13 star equal to 6 minus I, A21 star equal to 2 plus 5i, A22 star is 2, A23 star is I, A31 star is 6 plus I, A32 star is minus I, and A33 star is 4. By putting the complex conjugate each row as column, we get the transpose conjugate matrix as A theta equal to 1, 2 plus 5i, 6 plus I, 2 minus 5i, 2 minus I, 6 minus I, and 4. In our previous video, we have discussed the complex conjugate and transpose conjugate of a matrix in detail. The link of that video is given in the description box. Now, if we compare A and A theta, then we can write A is equal to A theta. So, A is an example of Hermitian matrix. Here, A is a square matrix of order 3 by 3. So, it is satisfying condition number 1. Again, A12 and A21 are complex conjugate. Similarly, A13 and A31 are complex conjugate, and A23 and A32 are complex conjugate. So, A is satisfying the condition number 2. Again, the diagonal elements of A are 1, 2 and 4, which are real. So, it is fulfilling the condition number 3 too. Now, let's move to skew Hermitian matrix. A matrix A is called skew Hermitian matrix if it is negative transpose conjugate of itself. That is, A is equal to minus A theta. The conditions for a matrix to be skew Hermitian are: number 1, the matrix should be square matrix. Number 2, the ith element should be negative complex conjugate of jth element. Number 3, the diagonal elements should be either imaginary or 0. For example, if we take a matrix A whose elements of the first row are A11 is 0, A12 is 2 plus 5i, A13 is 6 plus I. The elements of the second row are A21 is equal to minus 2 plus 5i, which can also be written as minus 2 minus 5. A22 is 2i, A23 is minus I, A31 is minus 6 plus I, which can also be written as minus 6 minus I, A32 is minus I, and A33 is 0. The complex conjugate of these numbers are A11 star is 0, A12 star is 2 minus 5i, A13 star is 6 minus I, A21 star is minus 2 plus 5i, A23 star is minus 2i, A23 star is I, A31 star is minus 6 plus I, A32 star is I, A33 star is 0. So, we get the transpose conjugate matrix as A theta equal to 0, minus 2, minus 5i, minus 6, minus I, 2 minus 5i, minus 2i, I, 6 minus I, and 0. This matrix can also be written like this. By taking out the negative sign as common, we get A theta equal to minus of 0, 2 plus 5i, 6 plus I, 2 plus 5i, 2i, minus I, 6 plus I, minus I and 0. If we compare A with A theta, then we can write A is equal to minus A theta. Here, A is a square matrix of order 3 by 3. So it is fulfilling the condition number 1. Again, if we compare the ith element to the jth element, then we get the complex conjugate of A12 is 2 minus 5i. So 8 to 1 is negative complex conjugate of A12. Similarly, A31 is negative complex conjugate of A13 and A32 is negative complex conjugate of A23. So this matrix A is satisfying condition number 2. Again, the diagonal elements of A are 0, 2i and 0. So it is fulfilling the condition number 3. This is it for today. Thanks for watching.